Hello everyone, welcome back to this video on classic optimization problem, that is knapsack problem. Knapsack problem. Sorry. Knapsack problem. First, initially we'll look into total knapsack problem and then we will discuss why greedy method works best for fractional knapsack problems. Okay. So, as we have already discussed, we'll look into total knapsack problems and then dealing with greedy method, best option for fractional knapsack problem. Going into the introduction, imagine you are a thief with a bag that can hold a limited amount of weight, that is W. Imagine you are a thief with a bag where you can hold a limited amount of weight W. In front of you, there is a pile of valuable items. There is a pile of valuable items, each with its own weight and value. Each with its own weight and value. Okay? The question is, which item should you take to maximize the total value? Which item needs to be picked to maximize the total value? Okay. So among all these pile of items, which items you will pick to maximize the total value is our goal. Okay. Without exceeding the total weight of the bag. Okay, total weight limit of the bag, that is a condition. Should not exceed total weight of bag. Okay, this is the concept of the problem. So as we have gone through the introductions in algorithms, there are two popular versions to solve this problem. Two popular versions to solve this problem. One is 0-1 knapsack problem. And the other one is fractional knapsack problem. Okay. So, what is 0-1 knapsack problem? 0-1 knapsack problem is nothing but we can either pick an item completely or we can skip. We can either pick an item completely or we can skip. That is the idea of 0-1 knapsack problem. Now we'll see what is the fractional knapsack problem. We are allowed to take a portion of the item, even a fraction of it. Here we are allowed to take or pick a portion, we are allowed to pick or take a portion of the item or fraction part of the item, that is the difference between knapsack, 0-1 knapsack and fraction knapsack. 0-1 we can either pick an item or completely, we can pick an item completely or we can skip completely. Okay. Fraction knapsack problem, we can either take a portion or the fraction part of the item. This is the introduction of the video. So, for example, we have an example to discuss the problem and how to solve the problem. First, we will go through the problem. Let's take a quick example. Say we have a bag that can hold 50 kgs of weight. Bag that can hold 50 kgs of weight. Okay. We are given 3 items. Item 1, 2 and 3. Each holding a weight of 10, 20 and 30 respectively. And their values are 60, 100 and 120 respectively. Okay. Now, what are the steps to the problem? First, we'll compute value to weight for each item. We'll compute value to weight or value by weight for each item, each given item. First, for the first item, value by weight is 60 by 10, that is 6. And second item, value by weight is 100 by 20, that is 5. And third item, 120 by 30, that is 4. We have calculated value by weight as in the first step. Now, we will sort items in the descending order of their ratio, of this ratio. Now, we will sort the items according to the descending order of the V by W value. Okay. So, as per the descending order, we'll get the item as 1, 2, 3 itself, because this is 6, 5 and 4. The values are 6, 5, 4. We have sorted according to the descending order, that is second step is also done. Pick items greedily. If the entire item fits, take it, as in 0-1 knapsack. If only a part fits, then take the fraction. Okay. So, what is the total weight of the bag? That is 50 kgs. Imagine this is your bag which holds 50 kgs of weight. So, what is our greedy plan? We have to take entire item if it fits. Okay. So, first we will go with the highest value, that is 6. So we'll pick it completely. So, we will pick it completely, that is 60. We'll pick 60. Okay. Now, what is the second item? That is 5. We will take 100. We'll pick 100. So, first item value is 10 kgs and second item value is 20 kgs. That is up to 30 kgs we have filled, and we have a room left over for 20 kgs. First item value is 60. We have taken 10 kgs here for the first item. First item 1. We are calculating weight and value correspondingly at a time. 60 is the value and 10 is the kgs weight, and second item is 100 kgs value and weight is 20 kgs. So as per the bag already 30 kgs are filled and we have room left for only 20 kgs. So we will take 2/3 part of the third item. Okay. So what is the 2/3 value of the third item? We cannot take completely the third item because it amounts to 30 kgs where we have only room for 20 kgs now. So we can't take 30 kgs because our weight should not cross 50 kgs. We have to take only 20 kgs. Okay. So 2/3 of 120. What is 2/3 of 120? We are taking 2/3 because 30 is up to 10 plus 10 plus 10. Only two parts of total completely 3 bits. Okay. 2/3 counts to 20 here. That is third item. And the value comes up to 3 4s are 12, 40, 4 2s are 80. So the value comes up to 80. Third item. Okay. I hope it is clear why we are taking only 2/3 parts of the third item, because we are left with only 20 kgs. We have to occupy only 20 kgs, but where the weight is 30 kgs in the third item, we are taking only 2 parts of among the 3 parts of the third item. We are filling with 20 kgs here, and the value comes up to 2/3 of 120. That is 3 4s are 12, 20 and 80. The value comes up to 80. So here we have filled 50 kgs and the value is 60 plus 100 plus 80. Here we are picking only fractional part. If the entire item fits, take it. So we have taken first 2 items because the entire item is fitting. We have taken these 2 items. Only a part of fits, that is third case, only a part is fitting, then we are taking the fraction. Stop when the knapsack is full. The knapsack is full with 50 kgs. We are stopping the problem. So I hope you understand the difference between 0-1 knapsack and fraction. That's why the greedy algorithm works best for fraction rather than 0-1 knapsack. Okay. We have seen both the algorithms here, both the strategies in this example. So this is all explained previously. Now we are explaining using a simple pseudo code also. So finally, what is the goal of the problem is to maximize value within a given weight capacity. To maximize value within a given weight capacity W. This we have already discussed here. What is our goal is to maximize. Goal is to maximize value within a given weight W. Should not exceed. Okay, should not exceed W. So we are having items. We are having the items. So this is the function, and which takes items and maximum weight, and we have items with value and their weight respectively, values and their weights of the items respectively. We are calculating value by weight, and we are also sorting. Okay, sorting nothing but first step is nothing but sorting items by descending order of value by weight, and this step ensures that we pick most valuable per weight. Okay, most valuable per weight items first, rather than choosing the less valuable per weight. Okay, that is done in this step. Next, we are initializing total value to 0 first. Okay, total value to 0 first, and iterating through the sorted items as the items are sorted descendingly. We are iterating through the items for value weight in items, iterating through the items through sorted items for value weights in items. Will go through each item one by one. If knapsack is full, we will break. If knapsack is full, we will break. Next, so basically nothing much is done in this code. We are taking the list of items and we are calculating value by weight and sorting them in descending order, picking the most valuable items at the first, and we are taking fractional parts if necessary. If the items are fully accepted, we are taking full items. If only fractional items are necessary, we are picking only fractional items, returning the total value. So what is the time complexity? For sorting, for calculating value by weight and sorting in descending order, it is taking big O of n log n. And for selection, that is 0-1 knapsack or fractional selection, it is taking big O of n. So total time complexity is O of n log n, making it very efficient. Why greedy fails for 0-1 knapsack? As we have already discussed here, the greedy works best for fractional knapsack rather than 0-1 knapsack. We'll look into it right now. In 0-1 knapsack, greedy does not always produce the optimal result because you cannot take fractions. Either you have to completely pick the item or completely skip the item. We cannot take fractions. There are cases where this might fail. Okay, greedy might fail for 0-1 knapsack. For example, if one item has a high value but slightly exceeds capacity, greedy may skip it even if taking it alone gives maximum value. Okay, so sometimes there is an option you cannot completely pick the item because it exceeds the total capacity total or outstanding capacity. You have an option to skip only rather than picking it completely. In that scenario, 0-1 knapsack fails. Instead, dynamic programming is used to solve 0-1 knapsack optimally in big O of NW times. So instead of going for greedy, we can go for dynamic programming in 0-1 knapsack optimally. Okay, here dynamic programming works well. So what are the applications of knapsack problems? Resource allocation. Example, distribute CPU or bandwidth efficiently. Distribute CPU or bandwidth efficiently. Investment planning, maximize returns within budget. So already we have discussed what is our goal, maximizing the returns within the budget. Cargo loading and shipping, in shipping and logistics. Load cargo for maximum value without overloading. Okay, load cargo with max value without overloading. Okay, budget limited advertising or project planning. Choose best ads or projects within a fixed budget. Okay, choose best ads or projects within a fixed budget. So knapsack problem always has a constraint of limit. Okay, constraint or a limit. Thank you.